Welcome back, Loving Good Earth scientists. Today we are starting our weather unit. To begin learning about weather, we need to learn a little bit about air and the atmosphere. The atmosphere is a mixture of gases that surrounds a planet or a moon. We will be talking about the atmosphere surrounding Earth and how the air or the gases in our atmosphere affect the weather on Earth. If you had to describe characteristics that all air had in common, what would you say? Well, let's go ahead and look at these characteristics or properties and see how the labs we did in class are examples. All air has pressure. Air pressure is the amount of air pushing down on an area or surface. I would write that down in the notes section for station number 2. In lab station number 2, is air there? You should have found that it was easier to push the bag into the can, but it was harder to pull the bag outside of the can. Why did this happen? Are you so weak that you can't pull a bag out of a coffee can? Well, the air inside the can was pushing on the bag. However, there was so much more air on the outside of the can pushing down that you had to pull pretty hard to pull past that great amount of air pressure. Air has pressure, and sometimes air has high pressure, and sometimes air has low pressure. This is important to weather. So, where was the air greater? In the can or outside of the can? Also remember that air pressure increases as you get closer to the Earth. This is because as you get close to the Earth, there is more air pushing down on you. Think of it like a human pyramid. The people on the top have less pressure than the people on the bottom. The air at the top of the pyramid has less air pressure because there is not as much air pushing on it as the air at the bottom of the pyramid. At station number 3, you should have learned more about convection. So let's add some information to our notes for station number 3. Convection is the transfer of heat by the movement of a fluid. Now, a fluid could be magma in the mantle, a fluid could be air, a fluid could be ocean currents. When you put the smoke over the chimney and there was no heat source or candle burning, nothing really happened to the smoke. However, when you lit the candle and put the smoke over the candle, you saw the smoke rise above the heat and sink on the chimney where it was cooler. This happens because of convection. Heat causes the fluid to rise because it is less dense, and cooler fluids sink because they are more dense. This is also a very important concept, along with pressure, as to how weather works. You should not be able to tell how air moves. You should now be able to tell how air moves in the atmosphere. It's similar to the convection box. Hint, 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 hint. At station number 4, you kept water in a jar with an index card. How did you do that? Well, the air under the card pressed the card up so the water would not come out. Remember, air does have pressure. Station number 5 was all about mass. Does air have mass? You should have concluded that the mass of the balloon deflated was different than the mass of the balloon inflated with air from a bicycle pump. Why was this? Well, mass is the amount of matter in an object. Air has matter. Therefore, air has mass. At station number 6, the candle went out, and the water inside the glass started to rise. This happened because the air in the glass warmed up when the candle was lit. The air expanded, took up more room, and created more air pressure on the glass and the water. When the candle went out, the air cooled down, contracted, and the air pressure became lower. This low air pressure inside the glass was less than the warmer air outside the glass. The water was then pushed up into the glass due to the differences in air pressure. Cool air has higher air pressure, and warmer air has lower air pressure. Station 7, you had a balloon on a bottle. When the bottle was immersed in cold water, not much happened. When the balloon was immersed in hot water, the balloon blew up. This happens because air has mass and air has volume. We know that if an object has a mass and a volume, then the object must also have a density. We know hot air rises like a hot air balloon because it is less dense. Cool air sinks like in a cold ocean current because it is more dense. At station 8, you were able to put a napkin in a beaker of water upside down, a napkin into a beaker of air and turn it upside down into a glass of water. The napkin never got wet. You also captured a cork in a bottle. When the bottle went under water, the cork moved with the water and eventually went to the bottom of the beaker. This happens because air has volume or takes up space. We know this because the cup in both demonstrations was filled with air. Air also has pressure, so the air pushed the water out of the way and the cork went to the bottom in the glass of air and the napkin stayed dry in the glass of air. Heat transfer is also important as we talk about weather. On the bottom of your notes, write these 3 definitions of how heat can be moved from one object to another object. Conduction is the direct transfer of heat from one substance to another. For instance, I touch my hand to a stove and it burns. That's conduction. Radiation is the transfer of heat by electromagnetic waves. Thank goodness I don't have to touch the sun to feel its heat. I feel the sun's heat because it's traveling as electromagnetic waves. The same thing for a fire. And convection, as mentioned earlier, is the transfer of heat by the movement of a fluid. Now, fluid can be a liquid or it could also be a gas. Let's think about a marshmallow. With conduction, if I put my marshmallow directly in the fire and catch it on fire, well, that would be conduction. If I put my marshmallow to the side of the fire and get it nice and toasty brown the way I really like it, well, that's radiation. The fire never touched the marshmallow, yet it still heated it up. Well, and then convection, when I'm at the campfire, the smoke rises. Why does it rise? That is due to convection. Hot air is less dense, so it rises. Thank you for learning about air and the atmosphere. See you in class.